This video is going to look at calculations involving gases because obviously chemistry involves lots of chemicals that may be in a gas form. Now, to do this video you really should be familiar with moles, mass and RFM and how to use that equation, and that will help you a lot when you're looking at the other calculations to do. So there's a reminder of what we should know already, that if we have a substance that is weighed out in grams, often a solid but could be a liquid as well, then we can weigh its mass in grams. And from the periodic table, that will tell us what the mass of 1 mole is in grams. And from that we can work out how many moles we have. For example, carbon on the periodic table has a mass of 12 atomic mass. So that tells me that 1 mole weighs 12 grams. So if I had 24 grams of it, 24 divided by 12 tells me I have 2 moles. Very simple, and there you can do lots of practice of those. So how is that different for a gas? Well, what I had to do with my carbon example that I just talked about is I had to go on the periodic table to find this amount here. This mass is from the periodic table. And I have to do that every single time because every single element, every single compound is going to have the different mass of 1 mole. And that's because every atom contains different numbers of protons and neutrons, and so every atom is going to have a different relative mass to other atoms. So every time I weigh something in grams, grams can't be compared between atoms without taking into account the different relative masses of the atoms. With gases though, I wouldn't necessarily want to measure the mass because it's quite easy to measure the volume of a gas. In chemistry we measure the volume in decimeters cubed, and that's the same as a litre. We just use it because it's a standard unit that uses meters, and meters is a standard unit for length. So a decimeter cubed is the same as 1 litre, like the size of a couple of small bottles, personal bottles of Coke. They're about 500 mils each. Okay, and so we can measure the volume of the gas. If I wanted to therefore work out how many moles, I'd need to know what 1 mole took up in terms of volume. In the same way that if I had mass in grams, I'd need to know what 1 mole weighs in order to work out how many moles I've got. The great thing about gases is that the volume of 1 mole does not depend on what the gas is. So in fact, the volume of 1 mole, so here's the triangle just in the centre, is fixed. And it's fixed given that we do all of our calculations at GCSE at the same temperature and the same pressure. So if you remember back in the day, earlier this year, you were probably drawing pictures of the particles in a gas. And the particles in a gas are really, really spread out. There's a really big distance between the particles. In fact, this diagram isn't even to scale. These particles are way too big for the spaces between them. Okay, so the space between particles in a gas is huge. The only way you can change that space really is if the particles moving faster, they'll spread out more, and they do that at a higher temperature. Or if you try and compress the gas, because we know that we could squash the gas in maybe a syringe or a balloon, then obviously that would change the volume that the particles took up too. But because we're doing everything at the same temperature and the same pressure, that means the space between the particles is the same, and the size of the particles doesn't matter. So if I drew that box, same size box roughly, and I had bigger gas particles or even heavier gas particles, it wouldn't actually make a difference to how many particles there were in that box. Okay, so the number of moles would be the same for the same volume of gas at room temperature and pressure. The other great thing about gas calculations is this number here, 24 decimeters cubed, would be given to you in a question. So in a question you would expect to be given the volume in decimeter cubed, you'd be given the 24 and told that that's the volume of 1 mole, and you'd have to work out the number of moles. almost seems too easy, and so therefore there are a few ways that volume calculations could be a little bit harder. One thing is the question could give you a different unit of volume. Normally we don't measure things in litres. We don't normally collect litres of gas. In an experiment, we normally collect centimetre cubed, which is the same as a millilitre. And what that means is that 1 decimetre cubed is equal to 1000 centimetre cubed. So there are two ways I can approach the type of question where I'm given centimetre cubed. One thing I can do is I can divide my amount in centimetre cubed, my volume in centimetre cubed, by 1000 to get decimetres and divide by 24, which was the previous triangle. Or if my volume's in centimetre cubed, well, 24 decimetre cubed, which was the amount that 1 mole of gas takes up, would be equal to 24,000 centimetre cubed. So I could just substitute the centimetre cubed value into my equation, because dividing by 24,000 is the same as dividing by 1000 and then dividing by 24. Doesn't matter which way round you do it, we'll show you both in the following calculations. Okay, so one example, find the volume of 2 moles of hydrogen gas. It's given the formula, but actually I don't need to use it because it's a gas. Is take my 2 moles, the volume of 1 mole is 24 decimetre cubed, and so that would give me 48 decimetres cubed. Easy peasy. So actually all okay, need to do the next one, 0.7 moles of carbon dioxide. So okay, I might not be able to do this one in my head, but the maths is the same. It's number of moles times how much volume, 24 decimetre cubed, that 1 mole takes up. And so I would do that on my calculator and I would get 16.8 decimetres cubed. So far very easy. Marks available, it would only be 1 mark for this sort of question. Okay, next one. This time I've been given a volume and I'm trying to find the number of moles. Again, I don't have to use this formula yet. The reason I don't need to use this formula is because it doesn't matter what the gas is. If I have volume, I'm just working from that. So all I would do is my moles, number of moles, equals the volume that I have in decimetre cubed divided by 24. So that would be 12 over 24, which is 0.5 moles. Another example, this time 600 centimetre cubed of ammonia gas. So I'm going back to this triangle, how many moles, I want number of moles, and I've got centimetre cubed, but this has given me a decimetre cubed. So one way that I can do this is I can convert 600 centimetre cubed into decimetre cubed by dividing by 1000. So that will give me 0.6 decimetre cubed. Now that I have my number in decimetre cubed, I can do exactly what I did before. Number of moles is my volume in decimetre cubed, 0.6, divided by the volume in decimetre cubed that 1 mole of gas takes up, 24. So I'm expecting a small number here because that's clearly much less than 1 mole, 0.025 moles. So it's often going to be the case that you do get very small numbers of moles, because even 600 centimetre cubed is a large amount and much larger than most of our measuring apparatus. Most of our measuring apparatus doesn't really measure much more than, say, 50 centimetre cubed of gas. The other way I can do this question, though, I mentioned, is if I'm given the volume in centimetre cubed, I can just directly divide by 24,000. So let's try that. I've got 600 centimetre cubed. My number of moles is going to be my volume in centimetre cubed divided by the volume in centimetre cubed of 1 mole. So the volume of 1 mole in centimetre cubed is 24,000, if I do 600 divided by 24,000, it's obviously going to give me the same result, 0.025 moles. Okay, this is where it gets a little bit harder. This time I'm asked to find the mass, not the number of moles, and I'm given a volume in centimetres cubed. So why is this harder? Well, if I look at my two triangles that I've learnt, these two formulae in this topic, I will see that mass in grams is up there in that formula, but I'm asked to find the volume, and volume is in this triangle, so you can't do anything with these two numbers directly. You can't just try and times them or divide them because they're not in the same formula as each other. But what is in the same formula is number of moles. So if you can find the number of moles from the triangle involving mass in grams, you can then transfer it to this one and find it the volume using our 24 decimeter cubed. So let's see how we would do that. First of all, I'm doing it the other way around. I've got centimeters cubed, so I go with what I've been given, centimeters cubed. From that, I could do what I did earlier. So my number of moles is going to be my centimeters cubed, 240 centimeters cubed. The volume of 1 mole in centimeters cubed is 24,000 centimeters cubed. And if I do that, I should end up with 0.01 moles. So that's my moles. And if I go back to here, that means I've used the volume to work out number of moles. So now I can go back to this triangle and work out mass in grams. I will have to then work this one out. Remember, I get that from the periodic table, so I could look that up. So we're finding the mass of 240. From 240 I worked out that was 0.01 moles. Now I need to use the formula because I need to work out the mass. So I look on the periodic table and I find that nitrogen weighs 1 and that 14, sorry, and hydrogen weighs 1. So I have 3 of those. So my RFM is 17. That's my mass of 1 mole. If I have 0.01 moles, therefore, my mass in grams is going to be the number of moles I've got, 0.01, times the mass of 1 mole, 17, and then I would get 0.17 grams as my answer. The final thing they could ask you to do is simply the same maths but the other way round. So we're still using both triangles here, both formulae. We're asked to find the volume, and I've been given the mass in grams, and I've also been given the formula. I'll need to use that as well. So I go back here, I've been given mass in grams, so if I find this on the periodic table I can work out number of moles. So I'm going to look up chlorine, and it turns out the mass of 1 chlorine atom is 35.5, times it by 2 and I get 71. So the mass of 1 mole is 71 grams. I've only got 42.6, so I work out my moles is mass in grams divided by the mass of 1 mole, in this case the RFM. So it's going to be 42.6 divided by 71. Pop that in my calculator and I get number of moles is equal to 0.6 moles. I then go back to my triangle. I've worked this out, so I can put that down there. I now know number of moles. I want the top number, I want volume, how much volume, so I'm going to times number of moles by volume. And so if I have 0.6 moles, as I worked out in the previous bit, then my volume is going to be number of moles, nom, times 24, because that is my volume in decimeter cubed. And so I would do 0.6 times 24, which is 14.4 decimeter cubed. If the question asked for it in a specific unit, so if it asked for decimeter cubed, I would leave it like that. And I would write decimetre cubed just to be really clear, because we can also measure in centimetre cubed. If I wanted to do it in centimetre cubed, because the question might ask me for that, I would times it by 1,000. So I would have 14,400 centimetre cubed as my final answer.